Hello viewers, welcome back to our YouTube channel, KC Accountants Education Center. And today we want to finalize with our cost of capital. And I want us to look at the last bit of our tutorials for this topic. And we want to, as we said in the previous video, we want to conclude with the cost of convertible debt, cost of convertible debt. So this is, of course, debt specifically, and it is specifically debentures in the capital structure, debentures or bonds in the capital structure. So you may find that the examiner has given what we call a convertible debenture or bond in the capital structure. And the examiner will tell you that this debenture is convertible. And when he does tell you, then you just know that it has some implications. And when he doesn't tell you, then of course it is the normal debenture that we know. But now a convertible instrument is that gives you a chance to convert it to either from debt to equity, or it could be from equity to debt. That is what we call the convertible instrument. Convertible instrument or asset is the one that gives you a chance to convert it. So the cost of a convertible debt is computed in the same way. We compute it in the same way, computed in the same way, like the redeemable debt. Redeemable. So the way we compute the redeemable debt is the same way we compute the convertible debt. However, one key thing that differentiates this is the fact that a convertible debt has two issues that you should know. One, it has a redemption value, and at the same time it has what we call a conversion value. It's these two items that distinguishes from the normal debenture to a convertible debenture. Now, what happens if you have those two items? Remember, if a debenture is redeemable, we said we compute IRR. Of course, we adjust it for tax. But now, you need to understand that when you are computing the IRR, in the last year of the project, you always have what we call a redemption value. But this time around, they have given you a redemption value at the same time they have given you the conversion value. The question is, which one of the two are we going to include in our computation? Because this is going to act like a cash outflow. We are redeeming back the money that we gave them. They are giving it to us back. So what happens is that you have to make comparisons. You need to compare these two items. You look at the redemption value and then the conversion value. You check which one has, or which one is higher. We take the highest of the two. If the redemption value is higher, we take the redemption value. If the conversion value is higher than the redemption value, then we go with the conversion value. That's the only difference. And the reason that's why we are picking the highest of the two is because when you are converting from debt to equity, of course you look at a situation where you are going to make more money because you're a business. That point where you are going to be making more money is what we should go by, or that we should go with. So if you are converting from debt to equity, it is because you want to make more money. And that's why we choose the highest of the two. So let's now look at the simulation. We get some small simulation so that we can put something in context. Simulation. Of course, this is a convertible debt. 8% and 8% convertible debenture has a current market value of UJEX 106 per 100. Full stop. The debenture will be converted. The debenture will be converted into equity. The debenture will be converted into equity shares in 3 years' time. 3 years' time at the rate of 40 shares per shillings 100 of debentures, full stop. They are continuing that the market price is expected to be shillings 3.5 on the date of conversion, full stop, required, assuming a corporation tax of 33%, what is the cost of capital? What is the cost of capital to the company what is the cost of capital to the company for the convertible debenture? So let's look at the solution. How best can we sort this? So, since the examiner remained silent on the redemption value, because we have not had anything to do with the redemption value, then we just assume that it was redeemed at par. Remember the other things I told you, you can redeem at par, you can redeem at par, you can redeem at discount, or you can redeem at a premium. But now, since the examiner, I said if the examiner wants you to redeem at discount or premium, he must tell you. If he doesn't tell you, then you shouldn't. Now, we are going to be redeeming at par because we are not told. It is standard, we redeem at par. So the par value, what is the par value of that? The par value is 100. So now, if the redemption value is 100, then we now want to look at the conversion value. Before we do anything, conversion value. So conversion value, how are we going to be able to compute that? They have told us that it is going to be 40 shares times the market price, which is 3.5. So this is going to give us 140 shillings. So we pick which one the highest. Of course, the highest is now the conversion value of 140. So we shall go by this 140. That's what I'm meaning. This is 140, this is 100. So we pick the highest. So having known that, then we know that for us to be able to get the cost the cost of a convertible bond. The cost of a convertible bond, we said it equals to IRR. We compute it in the same way that like we do for the redeemable debt. So cost of the convertible bond, convertible debenture, is equal to IRR. But we say this one, we adjust it for tax, if at all the tax rate has been given to us. But we said IRR, we know the formula. We said IRR equals to A plus capital A over capital A. This is plus capital B into B minus A. This is a minus. When you are writing the formula, this is supposed to be a minus, but when you are making the computation, you will just see that it is coming to be more of a plus sign. So we need now to first compute the interest that we are going to be using. So the interest, of course, the interest, they have given us the coupon, which is 8% times the par value of 100. So this is going to give us 8 shillings. So since it is giving us 8 shillings, then we can use the other method. We can get the net interest, or we can take it the other way. Let me take it and we compute. Of course, these are years. Of course, here we have the cash flows, we have the DCF, we have the present value, we have the DCF, and then the present value. So we start putting in the values. So we are starting from year 0. We are investing at the market value. Of course, the market value for the debenture they told us is 106. We are investing at 106. So first year, in year 1 up to year 3, we are going to be receiving what we call interest. It is 8. I've not adjusted for tax. So in the 3rd year, we are also going to be receiving the redemption value. We are redeeming, but instead of taking the redemption value here, we are taking the conversion value because it is higher, over 140. So what we are going to do now, we need to pick a rate. Let me just take 12%. 12%, this is going to be 1.00. This is going to be 106. Then we get the annuity factor. Annuity factor 12% in the 3rd year is 2.402. Then the present value factor 12% 3rd year is 0.71. Then we compute this times this is going to give you 99.68. Then we compute. Of course, this will give you the NPV, the first NPV. Then this is 8 times the 2.402. That is giving us 19.2. So we add the 99.68. So it is giving us a positive 12.9. This is a positive. So we increase the rate. If we take it maybe to 20%, so this is going to be 1.00. So we look at the present value factor, 10%, 20%. We are taking the annuity factor 3rd year at 20%. Annuity factor 3rd year 20% is 2.106. 2.106. Then we get now the present value factor third year at 20%, which is 0.5779. Then we start multiplying. So this is going to be 0.579 times 140. That is giving us 81.06. Then the 8 times the 2.106 is giving us 16.85. Of course, this is 106. So we get our second NPV plus the 81.06 minus the 106 is giving us a negative 8.09. So we take this, then we go to the NPV. We go to computing IRR. We wrote the formula already, so we are going to put in the raw rate, which is 12%, plus our A which is 12.9. This is 12.9 over 12.9 plus 8.09 times 20. Of course, 20% minus 12%. So this is going to be, of course, when you put that in your calculator, so this is going to give you 0.1692. So when you convert it to 100, it is going to give you, that is 16.92%. But remember, we need to adjust this for tax. So what we are going to do, we adjust it for tax. IRR, let me change the color. We adjust it for tax. IRR will be the 16.92% into the tax rate. They told us 33%, 1 minus 33%. So this is going to give you 11.33%, and that's going to be your cost of equity, your cost of convertible debt. So that's basically what we wanted to look at for the cost of a convertible debt. So what we are going to look at in the next video is going to be basically where we are going to be starting our new topic for capital structure theories. We are going to start capital structure and dividend policy, but we want to first look at capital structure theories. So that's what we are going to look at in the next video. Thank you for watching. Let's meet in the next video as we are talking about the capital structure or the dividend policy.